Hello, guys. So now moving on to example 10 in your electrostatics examples. Example 10 says, calculate the net electric field E at point X. This is point X, and we're going to calculate the net electric field at it. Okay? So before we proceed, you must see that we have two charged objects with object A that carries charges 30.7 nanocoulombs, which are negative, and object B, which carries charges, positive charges, of course, which are 50.9 nanocoulombs. The distance between point X and object B is 31.8 centimeters, while the distance between object A and B is 35.9. However, the distance between point X and object A is 31.8 plus 35.9, but we will look at it. For now, let me not add it together. Without any waste of time, let's calculate the electric field. So we're going to begin with electric field at X due to B. Okay, so let's continue. So the electric field due to point B. I think I should start with point B right here. With point due to point B is K Q sub B over R sub B squared. What is it? K is 9 times 10 to the 9. Charge of object B is, I think it was 50.9. Okay, so it's 50.9 nanocoulombs. Alright, so nano means 10 to the minus 9. The distance between object B and point X was 31.8 centimeters. 31.8. So 31.8, remember centi means 10 to the minus 2. Okay, let's get it. Okay, quick calculation. 9 and then 50.9 times 10 to the minus 9 over 31.8 times 10 to the minus 2 because it was centi square. So this is, let's see what is this? Okay, it was 31.8 centimeters. Okay, 31.8 centimeters. So this is 4,530,08188 Newton per coulomb. We're not done. Let's get the direction. This is a positive object or a positively charged object. So the charges will move outwards to point X. So they are moving to the left. Can you see that? They are moving to the left. So they are moving to the left. So the direction is to the left, right? Now let's calculate electric field at point X due to charge A. So it will be K QA over R sub A squared. And this is 9 times 10 to the 9. Let me check what object A was carrying. 30.7 nanocoulombs. 30.7 nanocoulombs. What was the distance? It was 31.8 times 10 to the minus 2 plus, what was the other one? 35.9. 35.9 times 10 to the minus 2 square. Now what is our electric field? Okay, let's get into it. My calculator is acting a bit slow. I don't know why, but it's okay. I'm gonna sort it out. The charge is 30.7, and the distance is 31.8 times 10 to the minus 2 plus 35.9 times 10 to the minus 2, right? It's okay to also write this as, I believe it's, let me see, it's 60 Okay, it's 67.7. I believe it's 67.7 times 10 to the minus 2, because you are adding 31.8 with 35.9. Right, yes, it'll be 67. It'll be 67.7. It's okay. All right. So what is your answer? Okay, your answer is 602.84206. Right? 84206 Newton per Coulomb. Okay? Newton per Coulomb. So let's check in which direction. So this object here is negative, right? This object here is negative. So since it's negative, the direction is going inwards. So this means it is moving away from point X, right? It is moving away from point X to object A. This means it's moving to the right. Okay? So this means the direction here is to the right. Sorry. The direction is to the right. Okay? It is to the right. Now, let's find our net electric field. So, E net will be due to point A plus, maybe, let me write it a bit down. E net will be due to point A plus due to point B. I will take a right as positive. Okay, I'm choosing the right as positive. Okay, I'm choosing to the right as positive. So, what was EA? EA was 602,84206 plus, let me check. It's going to the right, so it's okay. I wrote it as positive. EB is going to the left, so it'll be negative, right? It'll be negative. So it is 54530,081. Okay. So it's minus 4530,08188. Right? Now let's get it. 602,84206 minus 4530,08188. What is our answer? Our answer is negative 3,927,24. I am leaving it to 2 decimal places because this is our final answer. Now, this is 3,927,24 Newton per Coulomb, where you can see your answer is negative, and we said to the rightwards is positive. So we will say it is to the left. All right? It is to the left, and this is us calculating the electric field at X due to these two objects. Okay? All right. So this is it. We are done, and stay tuned for, it'll be your last example. I think it'll be your last example. All right.